Alrighty, folks, so I think we'll go ahead and get started with today's presentation. So thanks to everyone for coming out for our talk today. My name is Bryan G. I'm a research data librarian at the University of Texas at Austin, and I'm joined by my colleague Michael Shensky, the head of research data services at UT Austin. And Michael and I are going to be talking today about the work that we're doing at UT Austin to develop automated approaches to discover and assess research data and software outputs. Our objectives for this work are twofold. We want to develop open source programmatic approaches to efficiently identify research data and software that's produced by university researchers, and specifically to do so with workflows that can be readily adopted by other users, whether those are other folks in our library, other units on campus, or potentially other institutions. And then once we get that information, we want to analyze those data to make connections between research objects, articles, books, data, software, preprints, and so on, and to identify trends in data and software sharing, or lack thereof, by researchers on campus. Our motivations for this work, I think, are really similar to a lot of people who have attempted similar work before. We want to get a more comprehensive insight into the full research output of the university, especially as there's an increased emphasis on sharing of data, software, and other research outputs beyond sort of the articles and books that we're long accustomed to looking at. And especially for us in the libraries, we want to use these data to make data-informed decisions about the services and support that we're providing as part of the research data services team. How can we best support researchers based on the needs that we can identify in that community? So we're developing our own sort of open source solutions to this. And so people might ask, why are we not using proprietary solutions? For example, we subscribe to Web of Science for article tracking, for example, and these are really pervasive platforms that are used by libraries across the world. And there's a number of limitations that come with these. Proprietary resources are paywalled and build subscription dependencies that can be really challenging, especially in times of uncertain budgetary constraints. Proprietary solutions can often have more limited interoperability with other platforms, especially when thinking about downstream analyses, sharing of the data from retrieved processes, and they're closed source, which makes them a sort of black box. It's difficult to know exactly what's going on under the hood in a lot of these cases, and that can be really problematic when there are gaps or discrepancies in the data that are retrieved, if there are sort of notions about what should be expected. And I think the last limitation of proprietary solutions is really that they're primarily revenue-driven, right? That the decision about whether to maintain these resources and how to maintain these resources, it's going to be driven by whether these are generating revenue for their parent companies. And so some folks might be familiar with Elsevier's Data Monitor. This was their proprietary solution for doing this type of research data tracking. And they recently announced that they're going to be sunsetting this because it just didn't generate enough uptake for them. And so because this is closed source software, it's not possible for someone else to come along and pick up the maintenance of that. And so anyone who has a current workflow with Elsevier Data Monitor is now going to have to find another solution. And so these are things we're trying to avoid with an open source solution. So we use Python to develop our solutions, widely used programming languages. The code for this is posted in 2 public GitHub repositories, and these QR codes will show up again at the end of the presentation. But there's a lot of advantages, broadly speaking, to open source solutions. They facilitate greater access and reuse. Anyone can go access these right now, look at the entire code base, figure out what we're doing. It's more transparent and interoperable workflows. I think even if folks are not using Python for their own sort of process, for example, you can look at it, and if you have a modicum of understanding of how Python works, get an idea for the conceptual underpinnings behind how we've developed this process, and then adapt that if you wanted to do this in R, for instance. I think it's also really important that this approach that we're taking here with open source software really embodies the recommendations that we make to researchers in best practices around how to conduct their research and disseminate that, whether that's data or software. And I think that the last real advantage that comes with an open source solution is it gives us a lot of flexibility to develop custom, tailored approaches to work around a huge amount of obstacles to discovery. It is much more complicated to discover published research data and software than it is for articles, because of a huge range of variation, ranging from the conceptual, what are or is data, to the pervasive use of supplemental information, which is very hard to track programmatically, variability in use of persistent identifiers, DOIs, no DOIs, ARCs, handles, and so on, and then variability in data and software repositories, metadata capacities, what schemas they're using, what are minimum metadata requirements, and then these sort of curation and quality control attributes that they have in play. Now, oftentimes there's a lot of questions in digital scholarship about, does the infrastructure meet the needs of the community? And I think typically the answer is no. The infrastructure will always sort of lag a little bit. In theory, tracking institutional outputs in a programmatic fashion should be possible. Most DOIs for data sets and software, at least the ones that get DOIs, are minted through DataCite, which has a really robust and flexible metadata schema that supported affiliation metadata for over a decade now. Some people might also be familiar with the ROR identifier system, unique identifiers for research organizations, which in theory should help to address some of the problems of disambiguation and variable permutation construction for institutional names. But when we were starting out this work and looking at this, it was pretty clear that whether we were using ROR identifiers or looking at the single string for the official university's name, we're only getting a couple hundred data sets over a couple dozen repositories. And we know that this is not a complete capture or anything close to that because our institutional repository, which mints DOIs through DataCite, has over 1,300 deposits alone. And so we were missing most of those. And so that sent us really down this convoluted rabbit hole of looking in specific repositories, looking at specific deposits, looking at how that metadata got crosswalked to DataCite, how it's represented in schema. A lot of really graphic, gory details I'm not going to bore people with. But that really led us to uncover, I think, some not complicated, but perhaps not necessarily intuitive attributes that are important for trying to develop a more comprehensive programmatic approach. And so the first of these is, where do you find affiliation metadata? Most people who have done this work previously have only looked in one field, creator affiliation, because this is where you expect to find it. But the reality is that you might find it in other roles. Contributor is another role supported by the DataCite schema. And you could potentially find the institution being listed as a creator or as a contributor at the same level as an individual researcher, for instance, which is typically a metadata crosswalk problem and not a researcher attempting to assert that the university is equal partner in the generation of an output. I think the other one, and this will be particularly pertinent for folks at state schools, there's a lot of ways to write UT Austin, including a lot of ones that are not intuitive, a lot of unusual formatting, the ways you would not expect. And I think the big takeaway here is really that 70% of the affiliations that we are able to recover right now are not the official formulation for UT Austin, which is the University of Texas at Austin, the second one up there. I don't even use the official one usually. But so there's a lot of variation because ROR identifiers have not been widely adopted. You have this huge range of variability that needs to be accounted for. And so when we account for that, we look at multiple metadata fields for all sorts of different constructions at UT Austin. We go from a couple hundred up to about 3,000 distinct data sets after a lot of cleaning and deduplication over 65 repositories. And so we get our institutional repository, that's the Texas Data Repository, Big Generalist, Dryad, Zenodo, Harvard Dataverse, and then a long tailing string of specialist repositories of different specificities and domain topics. Now, obviously, we can get creative with looking in different affiliation metadata fields and coming up with all sorts of different ways to write UT Austin, but one of the principal challenges is going to be, what if affiliation metadata is simply not recorded to begin with? And this is commonly a problem with specialist or domain-specific repositories, but unfortunately, it's also a common problem in some big generalist repositories, which generate millions of data sets over their entire corpus. And so these are three examples here, all of which are funded by the NIH in part as part of the Generalist Repository Ecosystem Initiative, which is supposed to be developing minimum metadata standards and trying to create a certain bar for metadata. And in most cases, we're not going to be picking up deposits for these because we're not institutional members of these repositories. And so this creates this real gap in our understanding of where researchers are publishing, because we know they're using these platforms and we don't have an easy way to track them because their deposits are not going to record affiliation metadata. And so I think this leads to the challenges, but I think to me also the really exciting part, which is, can we discover the undiscoverable in an efficient fashion? So whether those are DOI-backed deposits that don't have affiliation metadata or non-DOI-backed deposits that do have affiliation metadata. And so I'll just be talking briefly about one of the sort of targeted approaches we've developed for the first one, DOI-backed deposits that don't have affiliation metadata. And so I'm going to be talking about Figshare. And so Figshare, like I mentioned, typically only records affiliation metadata for institutional members. We're not an institutional member, so typically we wouldn't see that much Figshare content. There are two ways to get deposits into Figshare. One is sort of the typical normal way people think of. Author logs in, Figshare, they create a deposit, put metadata, can't put affiliation, decide when to publish. It's entirely controlled by the author. There's a second process a lot of researchers and other folks are not aware of, and it's nearly an entirely automated process. And so Figshare partners with a number of journals and develops this system pipeline, basically, where content that's uploaded as supplemental information gets automatically ported over to Figshare, automatic metadata creation, automatic time release with the article once it's accepted and published. And so Figshare publishes with a lot of big publishers on this. And so there are easily over 1 million DOIs that have been minted through Figshare through this process. Again, most of them don't record affiliation metadata. And so in theory, it should not be possible to discover these. But we're able to take advantage in this case of other unique metadata attributes. And so I'm going to talk briefly about this workflow here. So typically, if someone uploads data to a repository, in the DataCite schema, the publisher is going to be listed as that repository. So Figshare in this case. For these journal-mediated Figshare deposits, the publisher is not listed as Figshare. It's listed as the scholarly publisher partner. So Taylor and Francis in this case, but Royal Society, PLOS, all sorts of different publishers. And so what we do in this case is we go through the DataCite API, the same source we used for the general capture, look for data sets that list the publisher as Taylor and Francis. And of course, almost none of these are going to have affiliation metadata. So we're getting a really, really broad corpus of just mediated deposits created by someone through a Taylor and Francis journal. But fortuitously, because these are linked through this automated process, they record the DOI of the article that they're supplemental to. And so we can get the list of these DOIs of articles that have had this automatic Figshare deposit created for them. And then we can do a separate query. We use OpenAlex. You could go through Crossref, whichever one you like for scholarly articles, and get a list of articles published by that publisher, so Taylor and Francis in this case, specifically authored by UT Austin researchers, and then cross-match those DOIs essentially. And so what we get in this case right now is about 180 Figshare deposits that have themselves no affiliation metadata, but that we can unambiguously link to articles that were created or co-authored by UT Austin researchers. And so we have in this respect sort of discovered the undiscoverable. We made a connection even though that primary object doesn't have that primary affiliation metadata. Now, in theory, we should be able to apply the same kind of process to research software, simply by swapping out the specification for looking for dataset to software, both of which are supported object types in the DataCite schema. But we know in the literature is well established that code sharing really lags behind data sharing because the policies around this have also really lagged at the funder and publisher levels. And in part, I think one of the other major challenges is the platforms that people are using for sharing software. And so we know, for instance, that GitHub, which is what we use to maintain the code, is a really popular repository for researchers to publish all sorts of materials, even though GitHub doesn't issue DOIs and lacks most of those requirements or characteristics that should be expected for a sort of a proper research data repository. And so these deposits, non-DOI backed deposits, potentially could have affiliation metadata. And so I'm going to turn it over to Michael at this point to talk about the work that we're doing on that software front with GitHub.
All right. Thank you, Bryan. So yes, I'm going to be speaking about the work that we have done that's somewhat analogous to what Bryan has been doing with published research data sets, and we're looking at research software being developed by researchers at UT Austin and trying to quantify that. This work was initiated after the establishment of the Open Source Program Office at UT Austin, which was established in August 2023 with funding support from the Alfred P. Sloan Foundation. The Open Source Program Office at UT Austin is a partnership between the Texas Advanced Computing Center, our enterprise technology team, the School of Information, the iSchool, and the UT Libraries, where Bryan and I are situated. And our focus through the OSPO, for these last 2 years since we've been established on campus is to help researchers progress along our participation pathway that we have defined that categorizes the level of involvement in open source software production and research. And so what we're trying to do is help researchers move along that pathway from starting to use open source software to publishing their own open source software to contributing to projects that others have developed to finally getting to the stage where they're able to accept contributions from other researchers themselves. And so we support researchers through training and events, helping them identify funding opportunities related to development of open source research software, best practices guides that we are building, and providing personalized consultation services to support researchers when they have specific questions. They can come to us to help find answers. And so we have a lot of these resources available through our Open Source Program Office website that we see linked to here, and it's accessible with that QR code. And as we were establishing this office, we're really trying to figure out how do we best provide these services, right? How can we make sure that we are reaching out to everybody effectively on campus that might have an interest in development of open source research software? Who are our most active researchers? How do we identify these key members of our community that we need to get engaged in the services that we are offering, that we need to reach out to help establish connections more broadly on campus and start to build that network? And starting to figure out what they're doing. So how are they collaborating internally? Are there missed opportunities there for connection on certain projects? How far along are folks on our participation pathway? Are they at the stage where they're just starting to use open source software or publish their software, or are they very advanced users? What programming languages are being used? We offer a number of workshops. Are we using the programming languages that are of most interest to our researchers when we teach those workshops? What licenses are being used or not being used? And how can we help researchers better understand the importance of software licensing when they decide to use GitHub to share their open source research software? And we want to be able to track how these things are changing over time as well. And so, again, as Bryan has already mentioned, we have decided to use Python and an open source approach to developing these processes for tracking both published research data sets and published research software. And with GitHub, we really decided to focus on this particular platform because it is so commonly utilized. And we realized that researchers who are publishing their software through GitHub might not be receiving a DOI. There is a process through that. Through which that is possible, that we have taught workshops on so that our researchers understand how that can be done, but that is not yet very common. And so our approach for identifying researchers that are active on GitHub and the specific projects that are owned by their accounts is to look in the publicly available account information that we can access using the GitHub API. So we have a Python script that retrieves information using the GitHub REST API, and we look for any indication that somebody has an affiliation with UT Austin. So again, this is all information that they are publicly sharing and including in their account information. This process generates 2 CSV files for us, one of which contains information about all of the repositories that have been identified as potentially UT Austin affiliated based on that account information, and another data set that contains information about all of the repositories owned by those accounts. And again, as Bryan has mentioned, this code is openly shared on GitHub itself and is available under an MIT license. So our methodology has been really focused on ensuring that this process is adaptable. Again, since we're just starting out, we want to provide ourselves with flexibility to adjust this as we're going along to make sure that it can continue to meet our needs, that we can continue to improve our ability to identify active researchers on GitHub who are sharing the open source software and have UT Austin affiliation. And we also want to make this an exemplar open source project itself. And so we want to, create this in a way that it can be successfully utilized by other institutions, ideally. We're very active in the open source program office community that has become very well established. And so we want to make sure that we are supporting that community by sharing our processes. In terms of our methodology, not only are we looking for that UT Austin affiliation, but there's other things that we can do with that too. So we're really interested in trying to identify who these folks are at UT Austin, and when we find that their account might have a UT Austin affiliation. So are they a faculty member? Are they a student? Are they an alumni or alumnus of UT Austin? And trying to figure out, why we might be finding their account and, filtering accordingly for certain types of analysis. So you can see the results from earlier this month about how we were able to categorize folks into certain categories based on our scripted process. And, based on some of the information that is shared in these accounts, it can be ambiguous at times. So there's not always that possibility of making a prediction that's going to be accurate. We have been able to identify almost 1,700 active GitHub accounts that potentially have UT Austin affiliation, again, based on that information that has been publicly shared through those accounts. So we see a screenshot here of what that data set looks like, some of that information being redacted here because of potential sensitivity that I'll talk about in just a second. And with those almost 1,700 accounts, we have nearly 36,000 GitHub repositories that we've been able to identify using the scripted process. And there's some really interesting information that we can start to glean when we do some basic analysis of the data that we've gathered. So one of the things I mentioned earlier is that we're interested in understanding, how folks are applying certain software licenses to the repositories that they are putting onto GitHub. And we can see from our data that most folks are not yet assigning a license to the software that they're publishing, but when they do, the MIT license is the most commonly utilized. So this is really interesting for us because it shows that this is something that we can really focus on in our best practice documents that we can talk about in workshops, the importance of selecting a license and why you might select a certain license. Also, as I mentioned earlier, when we are teaching workshops, we might be focusing on R or Python or some other language to help us communicate, research best practices or data management approaches. And we can see that Python is by far the most commonly utilized programming language in the repositories that we have detected as UT Austin affiliated, followed by JavaScript. And if we look quite a bit further down that list, we see R there, which again, we do frequently offer in workshops, but not as popular in terms of published data sets on GitHub. This information is being shared currently through our UT Open Source Program Office website. So we have over 8,000 repositories that have been listed here, and that's because we're only showing repositories that have been active in the last 18 months. So we want to make this information more digestible, and so we really want this to serve on this particular website as a tool for research matching. So one of the questions that we've received quite frequently since our office was established is, how can I get connected to an open source program office, open source project on campus? or how can I find students that might be interested in contributing to this open source project that I'm managing? And so this website allows you to visit and filter by certain keywords or filter by the type of programming language that's primarily used in this project. And that can help researchers identify projects that are active, that are managed by other researchers on campus that might be of interest to them. There are some challenges with this approach, some of which I've already alluded to. So we do have some difficulty verifying UT Austin affiliation. We might have somebody that's a big fan of UT Austin and they're, a supporter of our athletics program. So maybe they say they like, UT Austin and the Longhorns in their bio statement on their GitHub profile. Well, we're going to detect that as somebody who might be UT Austin affiliated when perhaps they are not. We also don't have the ability currently to find someone who has UT Austin affiliation, but is not indicating that publicly in their GitHub profile. How can we develop this process so that it's useful to us while also making it useful to other institutions that we frequently collaborate with? So we want to make sure that we are considering that as we build out these processes. How and to what extent do we share the data? So I just showed a moment ago how we're sharing that currently through our open source program office website. That's something that we have approached very carefully because of potential sensitivity about the data. I know this was something that came up in some discussions yesterday. What if somebody decides to take down information from their GitHub account? Well, if we were publishing this, for instance, through a data repository, that information would be versioned there. It would continue to be accessible there. And so they wouldn't have that ability any longer to completely take something down. With the approach that we're taking, it is going to be refreshed every several months on our UT Austin open source program office website. And so if somebody removes their GitHub information, they change their affiliation information, it should be removed from our data set. And we want to look beyond GitHub and look at other places where folks are maybe publishing their data to get a DOI, places like Zenodo, or perhaps other platforms similar to GitHub, like Bitbucket or GitLab. And so I've already mentioned some of the ways that we can use this information, that both Bryan and I are collecting. We can see how researchers at UT Austin are utilizing certain data repositories to publish their research data sets and how that is changing over time. So we can see that our institutional data repository, the Texas data repository, is currently by far the most commonly utilized, but we are definitely seeing growth in other repositories as well. Zenodo in particular has increased markedly in recent years, and that can help us inform how we are including data repositories into our workshops. Which ones do we focus on? What do we need to upskill on and make sure we understand all of the latest functionality in these repositories? If we're limited on time, which ones do we really dedicate our time and resources to? It can help us develop guides specific to these particular data repositories and allows us to look for really exemplary data sets that we can use as reference when we're talking to researchers and showing them what they should be doing in a data repository. So I've already mentioned again some of these things already as I've spoken here. This information that we're gathered can help inform how we are developing our workshops, what best practices documents we are focusing on, and how we can best develop those documents to help researchers avoid certain common issues. And we want to be able to start to use this data to understand how people on campus are interacting with one another and where there's the potential for connections that might be newly established. We recognize that we've made a lot of progress on the discovery front, but there is more work to do in terms of the analyzing the data that we've gathered and starting to connect, Bryan's data set about published research data sets to the information we've gathered about research software. So we certainly have a lot of work ahead of us, but we're really eager to continue making progress on this front and looking forward to what we might be able to discover moving forward. And with that, we have some time for questions and comments.
Thanks so much for this. This is really great and resonates a lot, I think, with some work inside my library at Stanford, but also our Dean of Research, who's doing a lot of work to try to think about contracts with other universities. And they're represented in exactly that same very diverse way that you showed, with UT Austin spelled all sorts of different ways. Talking with that office, I was just going to recommend to them that they think about edit distance and open refine and all these ways we can think about of sort of normalizing terminology. But I was thinking also about the power of kind of sentence transformers and some of these newer ways of reconciling semantic information. Have you guys played around with anything like that?
That's a fantastic question, and certainly something that we're eager to incorporate into our processes. So we're waiting to see, what new AI products might be rolled out at the institutional level that we can leverage. So for this type of work, we would really, want to have API access to a large language model or to be able to run this locally. Currently, we don't have the resources in place to do that, but certainly very eager to try that, especially for things like deciphering somebody's affiliate status. We were just talking about the GitHub repository. So somebody, a doctoral student, are they a faculty member? What exactly is their status? Right now, the logic that we're using is certainly not perfect. And I'm very interested to see if AI might be able to help us with that categorization process.
Thank
you. For tall people. I actually have two questions. The first one is, how many people approximately are working on your staff with this project?
Another great question. So Bryan and I are the two staff members that are dedicated to this work right now. We do have a third member of our research data services team within the libraries who provides GIS and geospatial data support. But that is not currently a specific component of the work that we're doing. So right now, it's really just myself and Bryan focused on the data and software components.
Thank you. And then the second question has to do with incorporating ORCID IDs. I didn't know if that would help maybe with the affiliations. I'm not.
Yeah, I can speak on that. I mean, I certainly know our some of our research offices have thought like, oh, we could get really comprehensive data, and then you show them like a researcher's or like bare bones ORCID profile, or you show them they don't have one, and they realize, oh, okay, a lot of people don't maintain it. We don't have a system, as far as I know, at UT Austin that like forces researchers to either have or to maintain their ORCID profile, and so that's part of it. I think one of the other things is that, so we're doing this with an affiliation-based approach, which I think is typically going to be the most reliable. Some people have tried to do this by getting like a list of researcher names and just feeding that in, but you obviously run into problems of like how many John Smiths are out there and, people moving between institutions or whatever. And we didn't have access to that list. I think there's all sorts of like HR sensitivity, different reasons why you might not be able to get that access to that list. We actually did just get access to that list like 3 weeks ago potentially, and so that could be a way that we could kind of up leverage some of that information as well. But I think, similar to ROR IDs, for instance, I mean, one, people have to have ORCIDs and maintain them. Two, they have to be willing to put it into the metadata. And three, like the repository has to be able to support that metadata. And so obviously for like, I don't know, platforms that don't issue DOIs, for instance, you're often not going to see that type of support to begin with.
Okay, thank you.
Hi, I'm Rob Ross from Ohio University. And at the beginning, you were talking about the commercial tools that most of us subscribe to, at least one of the three. Based on where you're headed, do you anticipate a tipping point where perhaps those are no longer necessary and you all feel like you could do this through the sort of work you're doing currently?
With a certain amount of money, maybe. I mean, I think that's always the challenge, right, is having dedicated time to do this. I mean, so like Michael's work is in part covered by, the funding for the open source program office. The work I do with the data is not funded by any sort of specific grant. I'm just doing it because I kind of like doing that kind of stuff. And it does kind of fall under my broad purview. I mean, I think the biggest advantage of commercial stuff is just the amount of resources, right? But I think that's an advantage, too, of open source stuff, right, is that you can really build momentum with the community effort to maintain and really diversify things. And, I think broadly speaking, as libraries think about how to, avoid subscription dependencies and try to manage budgets carefully, I think it certainly is a direction that things could go in to build that sort of resiliency and sustainability long term.
Well, I'll just leave you with this. I would say if you all sort of keep moving with this, I think a lot of us would rather give you some revenue than these other folks. So keep up with the great work.
Yeah. Thank you.
Hi, good morning. Thanks for a good presentation. I'm John Wheeler from the University of New Mexico. And a question I had, because Bryan was talking about data sets and the difficulty of discovering data sets depending on affiliation, but researchers do also store data sets within GitHub repositories. And I was wondering if I'm not familiar with the API, is it possible to mine that information that you're getting from GitHub to discover more data sets?
So I can talk about it at least to start. So this is sort of like a big thing. I mean, even when people deposit things in data repositories and they mint it as a data set, is it actually a data set, right? I mean, I think oftentimes many people be familiar, like researchers will just package their Excel files and their R code in the same thing, right? And so you have this like mixed object deposit or Crossref, for instance. Still mints DOIs for data sets, doesn't support software, for example, as a metadata object. So one of the things, at least on the data side, that I'm interested in doing is extracting like file name information and file extension information. I mean, it's not going to be perfect, for example, but if you get something that's like labeled as a software deposit, it's just an Excel file, I'm pretty sure that's not a software deposit, for instance. And so Michael can speak to more about the GitHub, but I think that's probably similar.
Yeah, and to Bryan's point, we might have software being deposited in research data repositories, and conversely, we might have data ending up in a GitHub repository. And we have not yet started to go through the contents of GitHub repositories to learn more about what's in there to see if it might in fact be data. There's so much room for future work here. I feel like we've accomplished a lot, but it still kind of feels like it's just the tip of the iceberg. So certainly that is something we are interested in exploring to get a better understanding of what specifically researchers are putting into those GitHub repositories. It's a great question.
Thanks.
Okay, well, I think that is the rest of the time for questions. But yeah, folks can feel free to come up and ask us more questions if you have any afterwards. And thanks for coming to our presentation.